In this final screencast for Chapter 8, we look at example 8.5. Graph each of the lines described below and then determine the equation of each line. Let's look at part A. In this case, the line we're interested in has a slope of 4 and it has a vertical intercept at y equals -3. So let's begin by sketching a graph of this line. I'll mark in a few tick marks. Okay, now for this line you're told that the vertical intercept is -3. That means the graph crosses the vertical axis at -3. It has a slope of 4. We can think of the 4 as 4 over 1, and we can think of it as change in output over the change in input. So whenever we change x by 1 unit, in other words, every time we increase x by 1 unit, we have to change y by 4 units. In other words, in this case, increase y by 4. So a slope of 4 means every time x increases by 1 unit, y increases by 4 units. So if I start from my vertical intercept and I increase x by 1, I know I have to increase y by 4. That brings me up to here. If I increase x by 1 unit again, y has to increase by 4 units, which would bring me, I guess, somewhere up here. If I connect the dots, I get my line. Now we want to determine the equation of the line. Every linear function has an equation of this form, y equals mx plus b. What makes one linear function differ from another linear function are the m and the b values. We need to figure out the m and the b values for this line. Well, in this case, m, that's the slope, you're told that's 4. And b, that represents the vertical intercept, which again you're told is -3. So the equation for this line is y equals 4x plus a -3, or rather 4x minus 3. Now let's go ahead and look at part B. This line has a horizontal intercept at x equals 4, and it has a vertical intercept at y equals 8. Again, let's start by graphing this line. Okay, that should be enough for tick marks. Now this line has a horizontal intercept at 4, at x equals 4, which I'll declare to be right there. And it has a vertical intercept at y equals 8, and that should be right here. I'll declare that to be 8. So the line passes through these 2 points. Its graph looks something like that. Now we need to determine the equation for this line. And again, we start from the equation y equals mx plus b. We need to determine the m and the b value. In this case, you're told what b is. B, as you recall, is the vertical intercept, which in this case is 8. In this case, you're not told specifically what m, or the slope, is, but recall that m is the ratio of the change in the output, which is y in this case, to the change in the input. Well, let's see if we can figure out these two changes from looking at the graph. Notice if we start from our upper point, 0, 8, and we go to the right and down, we can arrive at our lower point. The amount we go over, that's the amount we change x by. That's the delta x, which in this case is 4. The amount we drop, that's the change in y, which in this case is a -8. Negative because there was a drop. So the change in y is -8, change in x is 4, and the ratio between them is a -2. So the equation in this case is y equals -2x plus 8, or it might also be written as 8 minus 2x. Now let's go ahead and look at example C. This line passes through the point 0, -1 and is parallel to the line given by the equation y equals 5 plus 2x. Before jumping into this example, let's take a moment and talk about what the word parallel means. Parallel lines have equal slope. This should make some sense. Parallel lines are lines that never intersect. In other words, they would have to run side by side each other. If they run side by side, then they must have the same steepness or the same slope. Okay, now let's jump into part C. We're looking for a line that passes through the point 0, -1, and the line has to be parallel to the line that has this equation. Let's start by sketching a graph. So first of all, let's rewrite the equation of the line that's given to us. We can rewrite it as y equals 2x plus 5. From here we can see that the slope of this line, m, is 2, and the y-intercept, in other words the vertical intercept, is 5. So the line we're looking for has to be parallel to this line, and that means the same slope as this line. So let's sketch a graph. Okay, so the line we're looking for has to pass through the point 0, -1. So it has to pass through this point. Now the line we're looking for also is parallel to the line given by y equals 2x plus 5. Let's graph that line as well. That line has a vertical intercept of 5, so it passes through the point, let's see, 1, 2, 3, 4. Here's 5 right here. So it passes through 0, 5, which is right there, and it has a slope of 2, which means I go over 1 and up 2 to get another point on that line. So that line looks like this. So that line right there comes from that equation. So the line we are interested in will run side by side this line. Our line that starts down here must have a slope of 2. So if I go over 1 and up 2, I should get another point on that line. So the line we're looking for is that line right there. So that line will have an equation y equals mx plus b, and we need to figure out the m and the b for this line. Well, the m is the same as the m from the other line because the lines are parallel. So m is 2, and b, that's the y-intercept or the vertical intercept. And we can get that because we can see the vertical intercept down below. It's y equals -1. So b is -1. So the equation of this line is y equals 2x plus a -1, or rather 2x minus 1. Okay, let's move on to the next example, part D. In this case, the line we're interested in passes through the point 2, 6, and it is parallel to the line given by the equation y equals 4 minus x. So this problem is actually very similar to what we did in part C. So let's follow it the same way. First of all, I'm going to rewrite the equation that we were given. Y equals 4 minus x can be written as y equals 4 plus a -1x, which is the same thing as a -1x plus 4. So you can see from here that m is -1 and b is 4. So the slope of this line is a -1. That will be important for us because the line we want is parallel to this line, which means the two lines will have the same slope, namely -1. Now let's sketch a graph to see what this looks like. Okay, let's first of all sketch a graph of this line. This line has a vertical intercept at 4, so that would be right here, and it has a slope of -1. That means if I go 1 unit to the right, I drop 1 unit. If I go another unit to the right, drop a unit. Go another unit to the right, drop 1 unit. Another unit to the right, drop a unit. So that line looks like that. So that is that line. The line we are interested in passes through the point 2, 6, which would be right about here, and it's parallel to the red line, meaning it has the same slope, namely -1. So if I went over 1 unit to the right, I would have to drop 1 unit. So the line we are looking for looks like that. So that line will have an equation of the form y equals mx plus b, and we will need to figure out the m and the b for this particular line. The m we are given because this line is parallel to the other line, so they have the same slope, namely -1. Notice we can't tell exactly from looking at our graph what the y-intercept will be, so b is yet to be determined. So let's go ahead and find b. Right now we know that the equation must look like this, -1x plus b. And there's one other thing we know. We know that when x is equal to 2 on this line, when x is equal to 2, y has to equal 6. So that's an extra piece of information that we know. So this equation right here has to have this property. If I replace the x with 2, then I'm obliged to replace the y with 6, because this point, or rather this graph, passes through this point. So in other words, this pair of numbers is a solution of this equation. So let's go ahead and substitute 2 and 6 into the equation. So 6 will equal negative 1 times 2 plus b. So this says 6 is equal to negative 2 plus b, and this tells us what b has to equal. If we solve this equation for b, we find that b has to be 8. Does that make sense? Well, remember that b is the vertical intercept, or the y-intercept in this case, and we are concluding that it is 8. Well, if we look at our graph, if we marched our graph back to the y-axis, does it appear that the y-intercept could be 8? And it seems like it should be. So that gives us some hope that our work was correct. So the equation in this case is y equals negative 1x plus 8, or rather 8 minus x. Okay, now let's go ahead and look at part E. In this case, the line passes through the points 1, 1 and 4, 2. So let's begin by drawing a graph. Passes through the points 1, 1 and 4, 2. So the line we're talking about looks like that. Okay, we want to determine the equation of this line. Remember that all linear functions begin from the same template, so to speak, and we need to determine the m value and the b value. Now in this case, we cannot tell what the y-intercept or the b value is simply by looking at the graph. We'll have to figure that out. Also, we're not told specifically what the slope or the m value is, so we'll have to figure that out too. The first thing we do here is work out the slope. So let's find m. Recall that m is the ratio of the change in y, or the change in output, to the change in x, the change in input. And we can figure this out by looking at the graph. If I look at these 2 points, I can ask, how do I get from one point to the other point? Well, I had to go 3 units to the right. That corresponds to the change in x. So the change in x is 3. In other words, x increased by 3 units. Also, we had to go up 1 unit. So that's the change in y, 1, meaning we increased y by 1. So the ratio of these 2 changes, 1 to 3, gives us our slope. Now we want to find b. We know right now that y must equal 1/3 x plus b, and we also know two other facts about this line. The line passes through 1, 1, and it also passes through 4, 2. These are input-output pairs for this function. In other words, when x is 1, y has to be 1. When x is 4, y has to be 2. Those are solution pairs for this equation. Said another way, when x is 1, y has to be 1. When x is 4, y has to be 2. Either one of these two pairs can be used to find b, and we will get the same value of b no matter which pair we use. Let's go ahead and use the pair 1, 1. So we know that when x is 1, y also must be 1. Let's substitute these values into the equation. So we have 1 is equal to 1/3 times 1 plus b. Or rather, 1 is equal to 1/3 plus b. And from here you can see that b would have to be 2/3, because 1/3 plus 2/3 gives you 3/3, which is 1. So from here we can see that the equation of this line must be y equals 1/3 x plus 2/3. That's the equation for this line. Now it's worth pointing out that we could have used the point 4, 2. We could have said when x is 4, y is 2, and we would have substituted 2 and 4 in these spots. If we worked out all the algebra, like we did right here, we would have come to the same conclusion that b has to be 2/3. So it never matters which of the points you're given, you can use either one. One last observation. Does the 2/3 make sense? In other words, does b equals 2/3 seem like it could work with the graph? Remember that b represents the vertical intercept, the y-intercept in this case. So if we have b equaling 2/3, we're saying the graph is crossing the y-axis at 2/3. Does that seem reasonable? Well, if we look at where the graph is intersecting the y-axis, it does appear to intersect at roughly 2/3. So that helps us verify the work we've done.